Example 3, sketch the graph of the function f of x equals 6 over x squared plus 2. So this is a different type of rational function because you don't have a variable in the numerator. So we're not, we'll still use the same rules for asymptotes, but we don't need to convert it to a different form. So in this question, we will still look for vertical asymptotes. There are no NPVs, and I'll just show you algebraically how to confirm that, is if you try to solve for the denominator here, and you move this over, you would get -2, and of course you can't square root that negative number there to get a value, so there are no NPVs. If you think about it, no matter what you substitute in for x, and then you add 2, you're always going to get a positive number. So 0 squared plus 2, -2 squared ends up being 4, so you're always going to get a positive number. So this means there is no vertical asymptote on this graph. Now let's talk about horizontal asymptotes. For a horizontal asymptote, it's still the same rules. The degree in the numerator is less than the degree in the denominator of 2, so that means there's a horizontal asymptote at y equals 0. So we're going to draw that in. Okay, other than that, we want to make sure we check all of our intercepts. I know that there's going to be no x-intercept because I've got my horizontal asymptote there. Had you tried, it's just worth sort of showing you what would have happened if you would have tried to algebraically solve for that. So I put a 0 in place of y. 0 times the denominator would have given me 0 equals 6, and I don't have a variable anymore, and that's also not a true statement, so that would mean that confirms the none. The y-intercept, we're going to put in 0 as the x value, so we get 6 over 2, which is 3. So that's definitely a key point that's going to help me graph this shape. Okay, now I know it approaches the asymptotes, so I know it's going this way. Now I want to just sort of put in, it's hard to see my asymptote here. I just want to test a point then, so I don't know if it goes this way, how, like at what sort of degree of slope or shape it's going downwards. So I'm going to test a point. So I would plug 1 into the equation to see. So we're going to test x equals 1. So we get y equals 6 over 1 squared plus 2, and you get 6 divided by 3, so you're going to get 2. So this would be at 1 and 2. And I could have tested another point. You don't have to go test tons and tons of points. You just need a couple points to guide you. I want to see, it's most likely symmetrical. Quick confirming of that is if I plugged in -1, of course the results are going to be the same because -1 squared is the same, is also 1, so I still get 2. So that means -1 is also at 2. So there's my shape approaching the asymptotes then. So this is going to be curving along that asymptote here. So you're going to get this sort of bump type shape along the asymptote. So this strategy, you always know your rules of asymptotes. You always know how to find your x-intercepts. So if it's a graph that doesn't look familiar to you, you can always resort to testing points as well. And this is a good example of when you can do that.